Okay, today we're going to define average value in terms of definite integrals. Okay, the average value of a function is the value that would give the same area if the function was a constant. So let's go ahead and find the area underneath this curve 1/2 x squared. We can find that using the definite integral from 0 to 3. Take the antiderivative, evaluate at 3, and that gives us 4.5. So the total area is 4.5. If we wanted to find some function, some constant function that would give us the same area, we need to divide this by the width, 3, and we get 1.5. And so we'd end up with this constant function y equals 1.5 that also has an area of 4.5. So the average value is the area divided by the width, and we often write that as 1 over b minus a times the integral from a to b of f of x dx. 1 over b minus a gives you that width, and the integral gives you the area. And if you want to relate this to what you already know about average value, if we want to find the average of some set of numbers, we add up all the numbers and divide by how many we have. The integral is adding everything up, and we're dividing by the width. Okay, so let's find the average velocity in meters per second from 1 to 3, given the velocity function. So 1 over b minus a times the integral from a to b of v of t. If we evaluate this, we get 13 meters per second. And I just want to make a connection to something that we already know. If we're trying to find average velocity given position, that's something we've been doing since the very start of the year. So if we want to find the average velocity from time 1 to time 3, given position equals t cubed. Now notice the connection here. If position, s of t is t cubed, the derivative of that is velocity, which is 3t squared. So this is really the exact same question, we're just given some different information. Well, if I give you this question, asking to find average velocity, we take the difference in our positions at 3 and 1 over our elapsed time, 3 minus 1, which gives us 13 meters per second. So it's the exact same thing, we're just given different starting information. Okay, we have the mean value theorem for definite integrals. So we have the mean value theorem for derivatives, which we typically just refer to as the mean value theorem. The mean value theorem for definite integrals says that for a continuous function, at some point on the interval, the actual value will equal the average value. So we know how to calculate the average value, and some point at some value of c, the value of the function is going to be equal to that. And just to reiterate, if we just hear mean value theorem, we're referring to the mean value theorem for derivatives. If we're referring to the mean value theorem for definite integrals, it'll be called the mean value theorem for definite integrals.